Good morning, everyone. So the agenda for today is that we will begin with our take-home quiz number 8. We're going to cover that in its entirety and ask if you have any questions so that you can clarify anything you may be missing or misunderstanding, rather. Then we're going to see if anyone has questions from 5.4 material. That's the logarithms that we covered yesterday. We can look at the homework. We can see anything that you have questions about. And then I kind of wanted to begin 5.5 and give you a good overview of that before we end class today. And remember, today is Tuesday, so class does end a little earlier. We'll be done by 11:30. Okay. Any questions to start off with or any requests? All right. Let us begin. Everyone open up your notes to 5.1, 5.3, take home quiz number 8. Okay. Use f of x equals 2 over x and g of x equals x cubed to find the formula for each expression. We want to find f g of x. So that means multiplication. So f of x times g of x is what we're going to be doing. So this is 2 over x times x cubed over 1. That becomes 2x cubed over x. Because we have an x in the denominator and 1 in the numerator, we're going to say, well, we know that x can never be 0, but this doesn't actually ask for the domain. But if we were to say the domain, then we could say that x cannot equal 0. However, we can simplify this guy, and we see an x on the bottom and 3 x's on top. So that would leave 2 x's on the top when we simplify. So this would leave us with 2x squared. For those who may not understand that, when you multiply these out, you get 2 times x times x times x all over x. And if you were to come in here and cancel out the things that are on top and bottom, because dividing anything by itself is 1, we would be left with x, 2 x's and a 2. And that is the equivalence of that. Are there any questions of this? F of g of x means that we find g of x first and substitute that into f of x. So we're going to put g of x into f of x. So inside of f of x, we're going to type in a x cubed. So what that means is we're going to have 2 over x cubed. Are there any questions? No? Okay, so I'm asking y'all like these questions, if you have any questions, because I cannot read your mind, but I'm just going to say that I've been asking this for 9 weeks, so I'm gonna stop doing that. And if y'all have questions, I'm gonna just believe that you'll stop me and say, hey, what's going on? Okay, so using these tables, we're now going to put some things together. F plus G of 2, that means F of 2 plus G of 2. So F of 2 is 5. And G of 2 is 8. So that equals 13. Doing this is going to be really important for the test, okay? B, f of g of 0. That means put in g of 0 into f. So g of 0 is 4. And so f of 4 is 6. We're going to put -2 into g and then put that result back into g. So -2 is 0. G of 0 is 4. Okay. G inverse tells me that I don't actually have that table. So what I'm going to do for the people that need to see the inverse table is I'm going to write the inverse table. The inverse table literally just says switch all of the values from the top to the bottom. So when they say G inverse of 4, the answer is 0. If you were doing it the other way that I modeled in class, you would use the same table and just go backwards. You find 4 at the bottom and go to the top to see what it corresponds with. And that's 0. Moving on. F divided by G of 0. That means we're going to do F of 0 divided by G of 0. F of 0 is 0. G of 0 is -3. 0 divided by anything is still 0. This is F of 2 minus G of 2. F of 2, that's hard to see, but I believe it's 4. G of 2 looks like -5. So that makes +9. F of G of -3. That means we put, I'm sorry, -5. We put -5 into G. Whatever that value is, we put that into F. So G of -5 is 2. But then we say F of 2, and that's 4. G of F of -2. So we're going to put F of -2 into G. So first we're going to say F of -2. What is that? Looks like -4. And then we go and find -4 on our G, which is right there, +1. The teacher and me won't let me like skip this question. Do y'all have any questions? I said I wasn't gonna say that, but I have to. Okay. So when y'all say y'all don't have any questions, to me, that means everybody got this right. You understood it on the quiz and you are ready for the test. So I'll keep going. Use the graph to answer the following questions. Is this function 1-to-1? I'm going to say yes. And the reason is because it passes the horizontal line test. Okay. The reason makes sense. Anytime I draw a horizontal line, it literally is only going to touch one time. You'll never have a horizontal line that touches this function twice. Okay. And then it says find F inverse of 2. So there's a couple different ways to do this. We can find different values on the graph, like I had y'all do when you were in the breakout rooms, and make a table. So when X is 0, F of X is 1. This is 1, 2. This is 2, 5. So to find the inverse table, you just basically switch to 1, 0, 2, 1, 2, 5. So the inverse of 2, oh, this is 5, 2, sorry, is this one. So that tells us that the inverse of 2 is 1. Any questions? Okay. Let's see how many more. Dang, we got a lot on this quiz. Okay. Number 5. There are 4 quarts in a gallon. So the function Q of X equals 4X computes the number of quarts in X gallons. So like if you have 1 gallon, that's 4 quarts. You have 2, that's 8, 3, that's 12, so on and so forth. There are 2 pints in a quart. So the function 2 times X represents the X number of quarts, gives you the number of pints total. Find the formula for P inverse of X and explain what the inverse computes. So P inverse, so if we start with P of X equals 2X, we can write this as Y equals 2X. And we're gonna solve for X. So divide by 2. X equals Y divided by 2. And we solve for X and we're done. So X equals Y over 2. Now we switch the X and the Y. So switch these two guys. And we'll be given Y equals X divided by 2. And change Y to the inverse.
So for this one, I didn't show my work on the dividing by 2 and then switch the X and the Y. I just put the inverse of P is X over 2. Is that okay?
You can do that, that's fine. I just wouldn't be able to give you partial credit if because I don't know what your mind was thinking. In my opinion, this one is super easy, it's straightforward, because if the function is multiplied by 2, then you know the inverse is divided by 2. So like if you were just able to do that, then that's fine.
Okay.
Yeah. Okay. It says use your formula to find P inverse of 10. Well, if P inverse of X is X divided by 2, then this will remain 10 divided by 2. So P inverse of 10 equals 5. And it says interpret your answer. So, oh, I'm sorry, we didn't finish number 1. Number 1 says explain what the inverse computes. So if the function computes the number of pints in quarts, then the inverse would do the opposite, right? It would give us quarts and pints. So this is 5 quarts equal 10 pints. P of Q of X can be rewritten as P of Q of X. So we're going to start off with X, which represents gallons in the first equation. Once you put that in, then you get out quarts. and then we're putting in quarts, and we're gonna end up with pints. So Q of X, the equation is 4X. We're putting that inside of 2 times X. So we get that P of Q of X equals 8X.
Sorry to go backwards, but can you explain B, 5B again, please?
Yeah, for sure. So you understand the equation is X divided by 2? Okay, so then if it's X divided by 2, and they're saying find P of 10, that means they let X equal 10. So we put 10 in for X, so it's 10 divided by 2. 10 divided by 2 is 5. So what this means is that there are 5 quarts that equal 10 pints. Because X represents, in this case, pints in the inverse equation. Because in the straight equation, the original function, X represents the number of quarts. And our output is pints. But when we switch it for the inverse, X is pints, and our inverse of X is now quarts. So when we're putting in 10 pints and we come out with an output, that output represents how many quarts there are. So basically the X and the Y switch from what the original function was representing. Any questions?
I got all the math right, but the interpreting part is where I got so wrong. I was so
Okay. So I would say, Mia, the easiest way to think about this is literally switching everything. So go back to the original statement, which tells you what the original function computes, the number of pints in X quarts. So when you're thinking about the inverse, you think the exact opposite, the number of quarts in X pints. So just write it out in that way. Does that make more sense?
Yes, thank you.
No worries. Okay. So in C, are there any questions from anybody? How to do the composition? Okay. So now that we have this function, we know that this function equals like P of Q of X equals 8X. So we can just put in P of Q of 10 and make X equal 10. X still represents gallons. But when we substitute all those values in, we end up with the output is pints. So input was gallons, connector was quarts, and the output was pints. So we end up with 80 pints. So that means 10 gallons equals 80 pints. Because X started with gallons. It went to quarts. We use those quarts to then tell us how many pints. So that's how we start with gallons and end with pints.
I got that so wrong, but somehow I got it right. I mean, like I did it wrong, but I got the right answer. So
Okay. I mean, sometimes it's just your understanding of what you're doing is different, and it's totally fine. I love it because that's what math is. Like, you don't have to do it this way. As long as you understand, what we're hoping to get.
Mhm.
Do you understand what I explained right now?
Yeah, I understand it. So I did P 4 times 10, and then I got 40, and then I just multiplied it by 2.
That is exactly how you do it. You just did it in 2 steps. So remember, P of Q of X, that means Q of X is 4 times X.
Mhm.
And then P of X will be 2 times that. So you do 4 times 10, you get 40. Then you plug that in and do 2 times 40 and you get 80. That's the same thing we just did.
Okay, it's the same thing.
Exactly the same thing. Yeah. Okay, so number 6, for each problem below, choose the correct formula and calculate the answer. I personally like these, and because I'm telling you that I like them, I would star them on your paper. Okay? Because everything that you need is already given to you, and it's not really any like guesswork that you have to do. So suppose $1,700 is deposited into an IRA. That is the P, that's the principal amount. It pays an annual interest of 8%, that's my R. Calculate the final balance after 30 years, that's my T. Interest compounded quarterly, that's my N. So if I were to write down everything I knew, P equals 1,700, R equals 0.08, T equals 30, N equals 4. Round to the nearest cent, that means 2 decimal places. Okay, so in my formula, A equals P times 1 plus R over N times N to the T. I'm sorry, to the NT. So now we just substitute values. 1,700 times 1 plus 0.08 divided by 4 times 4, to the 4 times 30. I'm gonna stop sharing so I can share my calculator. Just a sec. So 1,700 parentheses 1 plus alpha y equals, so I can put in the fraction, 0.08 divided by 4. Get out of there, parentheses raised to the 4 times 30. 18,378 cents. Any questions?
I rounded to the nearest 10. Is that right?
So no, it would have to be to the nearest cent. So when it says the near, what's going on in my house? When it says the nearest cent, that means like 2 decimal places.
Okay.
So it have to be, to the nearest penny and not the nearest dime. Calculate the value, the final value. If you deposit 5,000, there's my principal, at an interest rate of 1.25%, so that's 0.0125. Compounded continuously, so I'm using my E equation. T equals 15. All right, so I'm using PERT. P E to the RT. So this is 5,000 E to the 0.0125 times 15. Sorry, let me get that out of the way so y'all can see. Okay, so 5,000 and then E to the 0.0125 times 15. That equals 6,031 and 15 cents. Questions? Mia, did you get that one right?
No, I did the same thing that I did with the last one.
Oh,
Instead-
you rounded to the nearest tenth.
Yeah, 0.2.
Okay, okay, but you did get the interest right. Yeah, I think that interest threw me off at first. I was like, it's a decimal for the interest already. So like, that don't let that confuse you. Um, if anyone looks at that, like just know you still got to move it two times. All right, so in this next section, I'm gonna say I like this one too. Um, here, what we're doing is more so just kind of thinking about what type of function is this, and we find that by looking at the change in the y values. So the change here, it looks like minus 40, but then all of a sudden it's minus 20. So you know it's not a linear change. So therefore, this is an exponential function. Because the change here is a multiplication and it's times 1/2. This is getting smaller by half every time. Times 1/2, times 1/2. So the initial value is that 0. You look for 0 on the chart and you see it's 20. So your C equals 20 and your A equals 1/2. So when we put this together, we get f of x equals 20 times 1/2 to the x. Whereas this one, it's a constant change of -10, -10, -10 every time. And the initial value was 60. So it's my M, my change is -10, my B is 60. So when I write this in function form, it's f of x equals -10x plus 60. And that's linear.
Does it matter if you wrote like 60 minus 10x?
Of course not. You are good to go. It's just convention, you know what I'm saying? Like when we talk about mx plus b, that's how it usually comes out. But it's totally fine if you wrote 60 minus 10x. Cool. All right, number 8. Here we go. Let's use this formula. You deposit $1,500 into a savings account. That's my C value, or my P if we were dealing with the interest formula. And it increases by 3% each year. So that's an increase of 3%. That's one, Lord, I cannot get it out. 1.03. Okay, so that's my A value. So when I put this together, f of x equals 1,500 times 1.03 to the x. Questions? Okay, and the last one says we have initial number of bacteria 500, so C equals 500. After injecting an antibiotic, the number of bacteria in the culture decreases by 3%. So we're going to be at 100 minus 3, which is 97% rate of change. So that's going to be a value of 0.97. Remember, if it's less than 1, it's decreasing. So f of x equals 500 times 0.97 to the x. And of course, you can make this like more legit and put 0.97. And that's that. Are there any questions? But that's that. That's the whole quiz. Yeah, we covered it all. I don't feel confident. I ain't gonna lie to y'all. I feel like I'm just talking to the sky. So if you do have questions, please let me know. As you prepare yourself for questions right now, go ahead and pull out your questions for 5.4. Okay. Look at your homework, pop in the chat if you have any specific questions on 5.4 homework, and we'll go over those. It's a lot of questions. Lord, it's 19. All right, I got some chats. All right, 16 and 17, boom. All right, number 16, we'll start there. If you find questions while I'm doing these, then definitely pop them in the chat. Okay. So solve the equation. 2 ln x minus 4 equals -1. Let me put my screen down. That's not cool. Okay. The first thing that you want to notice is that even though this isn't in parentheses, like this is ln of x minus 4, like that is together. It's not separate. Okay. So the first thing we'll do is we'll divide by 2 to get rid of that. And then we have ln of x minus 4 equal -1/2. At least that's how I see it. So let's see if that's right. I could be totally wrong. But to get rid of ln, we want to exponentiate both sides. Or we can just, you can see this in 2 different ways. Strategy 1 and strategy 2 is what we went over yesterday. In strategy 1, it says just understand what this is. ln of x minus 4 equal -1/2. That's actually log base e of x minus 4 equals -1/2. And so when you write this in exponential format, you can say the base is e, the exponent is -1/2, and the answer is x minus 4. Okay. The other strategy rather is to say, well, ln, the inverse of ln is e, so exponentiate both sides. These cancel, and you have x minus 4 equals e to the -1/2. Again, it's really just up to you about which one of these makes the most sense. So I'm going to put this in my calculator and find out what e to the -1/2 is. E to the -1/2. 0.6065. And it's x minus 4. So now we add 4 to both sides. Now I could be totally wrong in doing this entire problem wrong because they didn't have any parentheses in it. I assumed that these were parentheses, so I'm assuming my assumption could be wrong. So we might have to do this whole problem over. But that is the answer that I'm getting. Mia asked for this question. Mia, do you have any, like, what was your thoughts on it?
I was just confused on if I had to divide first or add first.
Yeah, so if there were parentheses, I would
Mhm.
say you divide first.
Okay.
Another way to do this problem, and let's just do both of the ways. So then that way we can be ready for whatever my math lab throws out at us.
Mhm.
Okay. So let's look at it as 2 ln, oh, no parentheses, sorry, x minus 4 equal -1. So then I would add 4 to both sides first to get rid of the plus. So then get 2 ln of x equals, what is that, 3? Then divide by 2. And then I get ln of x equals 3/2. And the way I would solve that is to exponentiate both sides. And that means that x equals e to the 3/2. And e to the 3/2, we just put that in the calculator, e to the 3/2. And so, yeah, that is one option. They're totally different answers. So we'll soon find out which one is correct. Do you understand why we do, like, why the difference would be?
Yes, but why do we get different answers if it's almost like kind of the same?
Because they're not the same at all. If this was an argument of ln, then you can't separate that 4 out.
Mhm.
You're taking the 4 away from the x initially. Whereas on this one, if it's no parentheses, you can move that 4 first. Whereas in this one, the 4 is removed last. You understand what I'm saying?
Yeah.
So that's why. And honestly, I'm really thinking that it's gonna be this second case because they didn't put parentheses. And I feel like my math lab would put parentheses if they wanted them there. So let us go here. Round to the 4 decimal places as needed. Lord. Okay, let's just check it and see. Hold on. I'm gonna go with my second answer because there is no parentheses explicitly written in the problem. So that was 4.4816, I believe. Check the answer. Nope. Oh, that would be the 4th decimal place will go up 1. You'll see that's an 8, so we'll push that 6 to a 7. So let me try that. This is really finicky. So the gist of this problem is that there is no parentheses, so we won't assume that, and that was my bad. So we could move the 4 first, and then divide by 2, and then solve for x, because it's not connected by parentheses. The hardest part is the rounding. Just, it says 4 decimal places, so you have to go to the 5th decimal place and see if it pushes it up or down, or stays the same. And in this case, it would push it up. Questions? Okay. Use the graph of f to sketch the inverse. So we know that the original function, I hate these because the graphs are just ridiculous to read. I'm gonna just pop it out. The original function is log base 4 of x. So the exponential opposite of that would be 4 to the x. So we just have to find out which one of these is a growth function. And that's A. A is the only one that has a growth function. Another thought about it is like if you were to fold the original like inverse function, if you folded this across the diagonal, the answer would be equivalent to A. Like if you folded it diagonally across the graph, then you'd end up with the answer choice of A. Are there questions about that?
No, I just had a question on part B on how to get f of -1.
Oh, my bad, it's another part. Let's keep going. F inverse of X, it's just the inverse of, like they gave you the function of f of X, log base 4 of X. So the opposite of log base 4 is exponent base 4. So 4 to the X power. The opposite of ln is e to the X. The opposite of log base 10 is 10 to the X. So you'll just take whatever that base is and raise it to that argument. Okay, because inverses and logarithms are, I'm sorry, exponentials and logarithms are inverses. So you just do the opposite. That's it. So the only questions that I had in the chat today were numbers 16 and 17. I can assume that you all already know how to do the rest of them, or you just need more time. So I'll let y'all have that time to do that. But for the rest of class today, I wanted us to have like a preview of 5-5. Okay. So if you all will go with me to, I'm sorry, are there any other questions on 5-4 homework? Okay, so go with me to 5-5. That's in assignments and resources, unit 3. And I'm just gonna pull up the lecture notes because you can follow along with Dr. Offer's video, but I want y'all to at least have a little bit of my understanding. And I'm gonna open it in my journal notes. All right, it's only 2 pages. 5-5 is really short, so I think we'll have time to cover it. At least give you an introduction to it. So this one, 5-5, is just kind of capitalizing on our understanding of logarithms, and it's now talking about logarithmic properties that will help us to easily solve things. So use the properties to evaluate the expression. So anything, any base to the 0 power gives us the result of 1. So when 1 is your argument, anytime you have a 1 in the argument, anytime you have a 1 in the argument, I can say that again, but I'm gonna not be weird. Okay, I will be weird. Anytime you have a 1 in the argument, your answer is 0. Anytime. Because the only thing that will give you a 1, the only exponent that will give you 1 is 0. So this one, B says 4 to the what power equals 4? Well, that's 1. So anytime you have the same base and argument, the answer is 1. There you go. Anytime your argument is 1, the answer is 0. So I could give you 1,000 questions on this and it would always be the same. So log base anything 1 is still 0. That's like a huge property that allows you to quickly solve questions. It don't matter what the base is, it's still gonna be 0 if the argument is 1. Yep, even smiley face. Okay. And then if it's log base 7 of 7, that equals 1. If it's log base 8 of 8, that equals 1. If it's log smiley face a smiley face, that equals 1. It don't matter what it is, because the only thing that will give you itself, the only exponent that will give you itself is if it's not multiplied by anything else. So the exponent of 1. These are 2 properties that you'll have to know. Log 10, well, that equals 1. Why? Because the base is 10. We know the common logarithm has a base of 10. So log that just asks you 10 to what power equals 10, 1. ln is base e as well. So this is e to what power gives me e? 1. That's the first section of 5.5. Okay. Section 2 is I think y'all learned exponent properties in high school, but I won't assume that. I will just go over those real quick. So let's say you had a value, like let's say you had, I'm gonna say x, x to the m, and you were multiplying that by x to the n. In high school, we should have learned that this is x to the m plus n. You add the exponents. If it's x to the m raised to the nth power, in high school, we should have learned that that was m times n. You multiply the powers. And this is just high school exponential properties, exponent properties. If you didn't remember them, it's totally okay. Just learn them now, okay? Anytime you have a number that's in the same base and it's divided by a number with the same base to a different exponent, what do you think you're gonna do with those exponents? Yes, m minus n, you'll subtract them. So division goes kind of hand in hand with subtraction. Multiplication goes hand in hand with addition. And when you're doing a power, you multiply the powers. Okay. Again, you should not have learned that right now. You should have learned that in high school. What we're about to do right now is actually expand on this and take this same idea to logarithms. So you can see a log of the same base. When the arguments are multiplied, that really means that you can separate them and add them together, add two separate logs together. When log of the same base are divided, you can separate them by subtracting them. Okay. And then this last one, if you have a log raised to a power, this one's kind of cool. You take that power and it becomes your coefficient. So you can multiply by it. Okay, so let's just do some examples, A through F. Example A, we have a base, then we have two arguments that are divided. So separating these, and we call this expanded form, okay? So we have log base 2 of x minus log base 2 of z. This is ln, so it's log base e. So ln of k plus ln of z. Because the k and the z are multiplied, so when we expand it out, we're just adding the arguments. Any questions so far of how you go from this condensed form to the expanded form? Okay, well, when you have it raised to a power, we end up with 2 times log 3a. But then don't forget that that log 3a, those two multiplications, so we can expand this even more. And we get 2 times, and I'm gonna put this in parentheses, log 3 plus log a. I'm gonna sit there right there and let y'all think about it. And y'all let me know if you have questions.
For that one, could you put the 2 like just in front of each of them instead of putting in a parentheses, and that would still be right?
Oh, totally. You can
Okay.
distribute that too, but don't forget, I'm sorry, distribute the 2. But don't forget that you have to distribute it if you do that. Okay. D is a little different. The 2 is not on both of them. It's not on the 3 and the a, it's only on the a. So for this one, I'm gonna say log 3 plus log a squared. And now when I write it out for the final expanded form, I have 2 log a. Any questions? Y'all understand the difference between C and D? Okay. This one will be log x cubed minus log k. But then that x cubed can be expanded out to say 3 log x minus log k. And this ln y cubed minus ln xz. So first step. Then this can be written 3 ln y minus ln xz. Ln xz is a multiplication, so we can write that as 3 ln y minus ln x plus ln z. You can stop right there, or you can distribute that negative. 3 ln y minus ln x minus ln z. Uh-oh. For the final answer. Any questions? Okay. The next page is like combining expressions. So it's just the opposite of what we just did. And my steps are just, my strategy, I'm sorry, is to go step by step. So log 5 plus log a is log 5a. You don't actually have to write it with parentheses because we know it's multiplied, but I like to put parentheses because it just has less confusion for me. All right, so this one is log base 2, log base 2. So I can write 1 log base 2. And this is x to the 4th power minus x. So it's divided by x. I don't really know if you should write it with the log base 2 of x cubed, because that actually is what it is. Either one of these would be fine. Okay, so this one is ln of 4 times x minus y. So this is ln of 4x over y. And it's just order of operation. So it's like addition over subtraction, but they can be done at the same time. So it doesn't really matter. Okay. And then the final one, this is going to be log base 5 x to the 6th power plus log 5 4x. And when they're added, that means they're multiplied. So it's just going to be log base 5 x to the 6 times 4x. And I can simplify that. Log base 5, 4 to the x to the 7th power. Because there are 6 x's in the first one and 1 in the second one. And they're multiplied, so add them all together. Any questions on that? Okay, y'all can get y'all some practice with the homework. My last one for this one is the change of base formula, which is probably the easiest thing on this entire page because I started this entire unit off with this. Question is, how would you put this in the calculator if you didn't have the log base formula? You'd put log base 33 over log base 6. That's it. That's it. That's all. Boom, you're done. Okay. With this one, we say log base 150 divided by log 2 minus log base 50 over log base 2. And this just means division, like this over this. So this is log base 150 divided by log base 2 divided by log base 50 over log base 2. Because they have the same denominators, we can disregard the denominators. So it'd be log base 150 over log base 50. That's just a fraction divided by a fraction. And you know when you divide in fractions, so I'm gonna just do this as an aside to people that don't understand how you can just disregard the denominators. You have 150 over log base 2, and that's divided by log 50 over log base 2. Well, when you're dividing fractions, that really means multiplying by the reciprocal. So you're multiplying by log 2 over 50 like that. Well, log 2 is on top and bottom. So you end up with just log 150 over log 50. That's how when we say, oh, they have the same denominators, you can just disregard them. You're not really disregarding them. You just know they multiply out to 1. Are there any questions?
Real quick, I guess so. One day
So I
we can
legit just taught
hopefully.
you 5-5. You could totally choose to watch this over in Dr. Offer's notes, especially if you like her teaching style, you know, where she explains it and explains it really slowly and well. Highly suggest that if you want to do that. If not, then just go ahead and start the homework for 5-5 and come to class tomorrow with questions. Because tomorrow's class, again, is going to be shorter. We'll probably be done by like 10:45 at the latest, okay? So just come to class tomorrow with questions over 5-5. Questions over 5-4, whatever questions y'all have. Think about the questions that you truly have, because I'm gonna just put some reality out there for y'all. Hold on. Let me do this without trying to beat you over the head. Hold on. Here it is. It's here. All right, reality check. Oh my goodness. We have, I can't get this thing out the way. Okay. We literally have 2 more days that you get to see me and talk to me before you take your last test. And a lot of people need to pass this last test. So 2 days of questions, then 3 days before the final. So we literally have 5 days that we're gonna see each other for the rest of the semester before your final grades are calculated. So reality check is if you have any questions over anything, just prepare them to ask in class, okay? Y'all be blessed. Let's actually, don't be blessed yet, hold on. Let me get y'all the attendance code. Check in for today. 8576. Oh, thanks. Yeah, I totally posted a review for Unit 3 late last night when I got home, and I'll post the review. I will post the review key tomorrow. I want to give y'all a couple days to actually work on it before you see the key. So I'll give you the key tomorrow. Any questions? Any other questions? All right, now my salutation. I love y'all. Y'all be blessed, and I'll holla. Stick around if you have questions.
Thank you.
8576.
Thank you.
Thank you.